and we're going to go over a few things on this particular lab. So what I've done is I've made some small jumpers, or you can purchase small jumpers. In this case I'll show you later on how to make those. And we've laid this out. Your board has this gap, so I've put bridges across two to make the power in and out complete. And we have, of course, our 33 ohm first, our 47, our 51, our 82, and our 100 ohm resistor. Now this forms a complete network. It forms a complete combination circuit, and I could have just jammed all these together on a single point on a row, but what I've done is I've put these in because you're going to have to remove those to start taking some readings on the current. Now the other thing is that the lead wires that we're using, I want to kind of show you a little trick you can sometimes do if you want. You can kind of see it looks like a little bit of a braid. It's increasing the surface area so that the alligator clips can grab hold of that better, and it's not that hard to do. You just take a piece of wire, and I'm going to use my fingernails because I don't have a stripper that small, and you want to strip off some extra wire. Then what you're going to do is take your needle nose pliers and you're going to try to bend it into thirds, sort of like that, and then you can twist it together. And what it gives you, by the time you're said and done, I've just got a little bit of a tail on that, but what it's going to give you when you're finished is something a little beefier for the alligator clip to actually get a hold of, as opposed to just the actual thin wire itself. So I've done that on both my negative lead and my positive lead. So my negative rail is now complete, so all of these are completing our circuit. We have 3 branches, plus we have a resistor in between, and as we know from the video and explanation in our theory course, that the power is going to come in, and every time it reaches a node, current's going to go in 2 different directions. So when we power this up, current's going to come here. It's going to take this, because it's a relatively low resistance path. It's going to, bulk of it's going to go this way, we expect. This is not presenting a lot of resistance, a slight bit more than this, but it's the balance of the circuit that we're interested in. So current's going to flow this way till it gets to this node, and then it's going to branch off in this direction and this direction. This last part here, of course, ends up making a series circuit. When this is connected to the return rail, this completes our circuit back to our power source. So the current that was split here is going to come back and is going to join up with the current that is flowing down this branch, which is then going to go to this node, and it's going to receive the current that is going down this branch to complete the Kirchhoff's law. So at every single node we should be able to calculate that the amount of current drop that we're expecting. Now when you completed setting this up and you've applied power to it, you're going to take a series of measurements, and those measurements are based on the resistor itself. And if you look at the book, it actually has jumpers in here that are telling you where to go. Now one of the diagrams, we're going to kind of change it because it's not, these two are the same, so we actually want to measure the current flowing from this point here. So we'll get to that in the video, so if you watch carefully. So what we're going to do is each of these little tiny jumpers, we're going to use that to open up the circuit and create and install a jumper wire. So I have another jumper wire set up, and you want it to be a fair length, because you're going to try to set that up so that when it's in the breadboard you can comfortably put the meter in, as opposed to these ones which are too small. So let's start off with our first measurement, and we want to get the total current. So in theory, the easiest way to do that would be, I'm going to move this so it's in our camera's view a little better. You could, once this is connected, you could literally just measure it that way. If not, and I'm just going to go through this because it's the process we're going to be going through the entire video. So I'm going to take this first wire out. Now you are probably going to say, yeah, but I don't have small wires like that. Okay, fair enough. I'm going to show you how to make small jumpers. It's a little counterintuitive. Normally we're taught as electricians that we're going to only strip off as much as we need. But what we're going to do is we're going to take more than we need. So I've stripped off way more than I need. And normally that's considered to be wasteful. But then I'm going to move the needle nose back, and I'm going to push that and start to strip it again. Okay, well, let's be nice to me. And you notice that the insulation is sliding through. Once I've done that, I have the potential to make a short jumper. So then all I have to do is give that a snip, like so, and I've made myself a small jumper. Now you might want to be a little bit more careful as to the balance, but if you hold on the wire, the insulation will move pretty easily. So now I've got two, I've got a nice straight edge. I can even bend it into a 90, bend my ends down if I want, and now I have a nice, this is the black, so I'm going to put it on the negative rail, and I've got a nice flat right angle to make my connections with, and you can make as many of those as you want and store them. Now, one of the things I want to point out before we get into taking all the measurements, etc., is notice that I've got these resistors trimmed and they're sitting right flat to the deck. It's the same thing that you'll find on a printed circuit board. You're not going to find resistors hanging around all over the place in big, huge loops. Everything is going to be neat and tidy and as close to the deck as possible. There's a couple reasons you're doing that. The first major one is it's a lot easier to see where your connection points are. When you were doing the parallel lab, you may have thought that you were completing the circuit, and all you have to be is off by a single hole, and suddenly it's not that circuit anymore. But each of these, I can follow them right straight through, and I can see that they're lined up simply because I've got them close and flat to the deck, and I can focus on where the connections are as opposed to this. So here's the alternative. I'm going to take this and this resistor out, and I'm going to replace them. Set those aside. So I'm going to take these 100 ohms. It's not the same circuit, I grant you, but I haven't trimmed these. I've just kind of bent them helter-skelter, and I'm just going to throw them in here. Make sure I've got it on the same thing. That looks close enough. And do that here as well. I'm not going to wobble won't go in. Straighten the wire a little bit. Tuck that into there. And kind of just shove that onto this over here. Kind of like that. Now you can begin to see the chaos. It's hard to see whether this is actually lined up. And it's an optical illusion given it that it's even bent. This one looks pretty all straightforward. This one, I'd have to kind of push it out of the way. Yep, that's connected. Oh, I missed one. And this is the problem. It's hard to see, especially given that I've got middle-aged eyes, and you'll come to me and say, I need some help with this. I have a hard time seeing it. My hair color is not a lifestyle choice. It's not from a bottle. So you're going to run into the same thing. So by keeping these nice and trimmed, and 3 to 4 holes is lots, you can see right away that that's lined up, that is in the correct spot. The other thing that I want you to consider and keep in mind when you're working and doing this sort of thing is that on these, notice that you should I've made a habit of putting the tolerance band in the same location. And that's simply so that when I'm looking at it, I know that I'm counting it this way towards it. So I'm trying to figure it out and say, oh, wait a minute, I've got those two backwards, because I can tell right away from the band itself. Alright, so the first measurement you're going to make is the total current. And if you're not going to use the power feed, you're simply going to take this little lead out, set it aside, and you should have prepared something around about 3 inches long, about the length of your finger is lots. And right where it was, in this case here I had it in the center of those two, off to my power rail, and I've got a nice large comfortable loop that my meter is going to fit in no problem whatsoever. So then I can take my full current for the whole system and read it. I'm going to then remove it, and important step, put the original jumper back to complete the circuit. So watch where it goes. Oops, that's in the wrong spot. I'm going to put that in the correct rail. And again, because it's flat to the deck, yep, I've got that done. I can even check it to make sure that my circuit all works. If I had it in the wrong spot, obviously the circuit doesn't work. And it doesn't take any time to use the leads to test. Okay, so now I need to know two things. I need to know the current that's running down this leg, and I need to know the current that's running for the rest of the whole circuit. So I'm going to start with this one, and notice I go over the moat, so it's really easy for me to remove that. I can bring some of these in, but I don't want you to stab yourself, so just take that out. Set it aside where I can see it. Take my jumper test lead, complete my circuit again, apply power, and again take my reading. One and done. Okay, or two and done, I guess. Now I'm going to put that back. Again, I can't stress this enough, you have to put it back, otherwise you just keep changing the circuit. Without this in here, let's look at our circuit. Now, it doesn't have this in our circuit at all. Our circuit starts here. We have a series portion, then we have a parallel series parallel, which is not what we're supposed to have. So let's put that jumper back in. And now it lines up nice and tidy, just like that does. So now we've got to remove this one, and we're going to do the same thing. We're going to replace it with our jumper. Notice I do not go back to the rail. I put it right where it was before. You can see I have to bend it over to show you, but I put it right back where the other one was. Take my reading. I'm done. Pull that out. Replace this. And I'm kind of talking fast, but this is not a long lab. This is not, like, it shouldn't take a whole bunch of time to do this. That's now done. I know that the current from here is going to be the same as it's going to be here. So if you wanted to, you could have removed this one. That's fine. It would have done the same thing. This point and this point, however, are different. So the next one I'm going to do is I'm going to pull this one out of the center. And I'm going to put the jumper in. I'm going to take my reading. Then I'm going to take my jumper out and put the small bridge jumper back in. And make sure it's lined up before I press Evu. That's now complete. So the current, we know the current is splitting here. Part of it's going that way, part of it's going that way. So now we have to find out what the current is flowing through here. Now on the drawing, it kind of shows this doing twice. In realistic terms, this is a series circuit, so moving it here or here shouldn't make a difference. But there will be a voltage drop at this point. So what we're going to do is we're going to pop this out, put this in here. Again, I'll fold it back to show you that I'm actually got it in the right spot. I'm going to take my measurement and I'm going to pop this out. And because there's a voltage drop in play, make sure I put that back where that belongs. The last measurement will be at this bridge here. The current should be the same, but if you measure the voltage, it should be different. So just to double check that Mr. George Ohm and Mr. Kurt Gustav Kirchhoff is not fibbing, I'm going to do another current reading here, and that completes all the current readings. The voltage readings, of course, you're going to just measure across each resistor. And again, it doesn't take a whole lot of time. And notice how easy that went by having these small jumpers. It's really easy to see the lab. It's really easy to see the layout. You can quickly follow it. You can try to jam things together, but I'm trying to help you with reducing the frustration down to an absolute minimum. Notice I never touched a single resistor after I showed you the big hoops. Once they're in place, you don't have to touch them. The only thing I'm touching are these little wires, and every time I've done it, I've made sure that I'm lined up. And because this back is always touched to our negative rail, it never changes. It's all good. And that's pretty much the lab. Now, there are times where they're going to ask you to calculate and measure the voltage. So you'll do that, and you'll have your resistance. But other than that, it's a straightforward lab, and as I say, it will take about as long as this video did. With that, we'll see you in the morning.